exactly. Yes, it is. Square root is the same as raising x to the 1/2 power. Matt, what's the cubed root of x? That's the same as writing what? X to the 1/3. See that? If I want the fourth root of something, that's actually the same as raising something to the 1/4 power. So if you had to make a general rule, what's happening to the root number? So this is technically the square root. Where's that going in the exponent? The denominator. The third cubed root is going to the denominator. The fourth root is going to the denominator. You with me? Then we're going to up the ante, and they're going to show you stuff like this. The square root of x to the 5th. We said that that root goes to the denominator, right? This is the same as x to the 5/2 power. If they ask you for the cubed root of x squared, that's going to be x to the what? Does anyone think they get the pattern, Kaylee? 2/3. If I take the fourth root of x to the 11th, Evan, what do you think that's going to be? The 11/4. Excellent. The root becomes the denominator. If there's a pre-existing exponent, that stays in the numerator. Squared. Technically, that's what happened here, right? Isn't this x to the 1st? 1/2. Isn't this x to the 1st? 1/3. Isn't this x to the 1st? 1/4. So the main rule is actually down here. And this gives the same rule in symbolic form. B to the m/n is equivalent to the nth root. See how the denominator is the root number out in front, and the numerator is the pre-existing exponent. Okay? Now, obviously this is radical form, right? If they say radical form, this is radical form. This is exponential form. The radical form is interesting because it can happen either way. Let's go back up to, I'll go up and use this space for a second. Let's pretend they give you 27 to the 2/3 power, okay? There's two different radical form versions of this. You can do, how do I want to present this? I'm gonna change the exponential form first. You know the power to power rule? When you raise an exponent to another exponent, you multiply. I could do this as 27 to the 1/3 power first and then square it. Do we all agree that that's equivalent? Because of your exponent rules, power to power means multiply. 1/3 times 2 is 2/3. Yes? Or I could write it like this. I could take the 27, square it first, and then raise it to the 1/3 power. Don't we agree that whether we do 1/3 times 2 or 2 times 1/3, regardless of the order, they're both 2/3? Because multiplication can be done in any order. Okay? So now if I take this version and change it to radical form, that's the cubed root of 27 squared. Versus this one is the 27 squared first, and then I'm taking the cubed root of it. Do you see that? So if I go back down to the symbolic form, that's kind of the logic as to why the m, the exponent here, can be written underneath the radical like it was here, or it can be written outside the radical like it was there. Now, if you're going to do this in your head, pretending you don't have a calculator, which method would you be able to do in your head first? The top or the bottom? Because order of operation tells you to do what first here? Tells you to take the cubed root of 27, which is what? The cubed root of 27 is 3. Square that, you get 9. This one, order of operation technically wants you to do 27 squared first. I don't know anybody in here that can do that in their head, right? So 27 squared, I'll do it on my calculator, but if you're doing it in your head, you want to take the cubed root first and then square it. Can I borrow your calculator, Bo? Or someone tell me, what's 27 squared? 729. So then you take the cubed root of 729, and guess what multiplies by itself 3 times to get you 729? 9. Okay? So you get the same answer both ways. It's just the order in which you do it. Whether you put the square outside the radical or inside the radical, I'm going to say outside the radical is better because you want to shrink a number first before making it huge. This one we made it huge first and then shrunk it up, but this kind of is easier to see because we know those numbers in our head. My point is also with exponent rules, power to power can happen in either order. So for the record, if you typed in on your calculator 27 to the 2/3 power, you're going to get 9. Okay? Any questions? Okay? So this first section, rewrite each expression in, this is just saying exponential form. Okay? So this is 5. Nothing happens to the 5, but the x is raised to the 1/2 power. Good. This one on our numerator, it's the 5th root of x, so that's x to the 1/5 over 4. In C, 7 over, what happens to the cubed root of x? X to the 1/3. And on the last one, 5 over 3 times, what happens to the 10th root of x? X to the 1/10. So that's going from radical form to exponential. Same thing down here, it's just now we're throwing, these are all in radical form, can you agree? Okay? What is this one going to become, Micah? Seven over 2, because it's technically the square root, right? Square roots, we're just in math, we're not forced to write the square. B, take a stab at it, Jake. X to the what? 6 over 4. Now, because that's a fraction that can be reduced, let's do that. X to the 3/2. For the record, let's pretend we were simplifying a radical. Because we're taking the 4th root, we want that number, that exponent, to be divisible by what? 4. So I would break this up into the 4th root of x to the 4th times the 4th root of x squared. Do we follow? Right? And so this is just x. 4th root of x to the 4th is just x. And this is the 4th root of x squared still. But this can become what? X to what power? 2/4, technically. And 2/4 is going to become x times x to the 1/2. And what is our exponent rule if we're multiplying common bases? What do we do with the exponents? Add them. And 1 plus 1/2 is 1/2, which is 3/2. See that? Just a connection. You're not going to probably have to do all that, but in different scenarios you have to kind of do radical form, do exponential form. There's a very, very strong connection with exponent rules here. Radicals are exponents. It's just a different way of writing it. Radicals are just fractional exponents. Isaiah? This one here, I just reduced 2/4. So this became 2/4, and then 2/4 became 1/2. Okay? Now this one, x to the, what would you say, Kaylee M? 6 over 2, and that of course is x to the third. Well, that's nice because it's a whole number. Isn't it also true, just kind of capitalizing on exponent rules, this is the same as x to the 1/2, right? Raised to the 6th power, supposedly. And what's our power to power rule? Multiply, and 1/2 times 6 would give you that 3 as well. Different avenues of getting to the same place. And then this one, x to the 8 10/3. Awesome. Okay. So, we have a function, exponential, and that, or it's got fractional exponents. Which of the following represents the value of f of 4? And it's silly if you have a calculator, but let's kind of conceptually think about this. If x is 4, so that's 10 times 4 to the 3/2 minus 24 times 4 to the -1. Now, 4 to the 3/2 is the same as, if I go back to radical form, what root is it? Square root, cubed root, which is it? Square root of 4 raised to what power? The third. Minus 24. What do negative exponents do? If I have 4 to the negative first power is the same as what? 1 over 4 to the positive first power. Very good. So then 10 times, what's the square root of 4? Okay, I'm not going to do 10 times 2, am I? Because I have to do exponents first. So this is going to be 2 cubed, which is what? 8. So it's going to be 10 times 8 minus, what's 1/4 of 24? Or what's 24 fourths? 6. So 80 minus 6 is 74. Exercise 4 is interesting. Which of the following is not equivalent to x to the -7/3? I'm going to write that a little more clearly. So 3 of these are equivalent expressions, and only one of them is not. So raise your hand if you think you can tell me one that definitely is the same. One, because a negative exponent means bring it to the denominator. So 1 is definitely the same. Once you have it written in the format of 1, what else is the same as that if you're going from that exponential format to radical format? Nate? 4 is what? It is one version of it. That's not, I don't think that's the way I would have directly gone. We're going to talk about that one. 3. Oh, choice 3. Gotcha. Oh yeah, 1, 2. Okay. Yes, because this is the denominator, so that goes out as the root. So that's the same. Which means this one is definitely not the same, right? Because they flip-flopped where the 7 and the 3 were. So that's the one that does not. 4, I guess I would say with 4, I would probably think of it first as making this the cubed root of x to the -7th. And then going from that to, instead of x to the -7th, 1 over x to the 7th. And that's how you can see the equivalence to 4. Good? Any questions? Okay. We are not doing this because we did it months ago. It would just be a review. And we are not doing this because we're not learning it until tomorrow. So, I knew this was going to happen. Don't worry, I'm prepared for you. This is the real, now that we've learned what a fractional exponent is and how radicals change to fractional exponents, this is what you're going to see on your Regents note topic. And it really is going to be a review of exponent rules. It's just now we have fractions involved. So we might be adding small fractions, multiplying small fractions, subtracting small fractions. And actually when I to already include fractions, so you would get used to having to do that. But, so A, B, and C are just exponent rule stuff. We'll come back to those if we have time, but we did that earlier in the year. Exercise 3, that's all exponent rules except for D. So let's look at D. It's going to be exponent rules, but there's a radical involved. Before we can apply exponent rules, we need everything to be written as an exponent. So the numerator is fine, x to the third. How do I rewrite the radical in the denominator? As a fractional exponent. X to the 1/2. Very good. Now what is my exponent rule when I'm dividing common bases? What am I supposed to do? Subtract. So this is just going to be x to the, what's 3 minus 1/2. I knew 2.5 is the obvious answer, right? But we're not going to have a mixed fraction in our exponent. Make it an improper fraction. So 3 minus 1/2 is going to be 6/2 minus 1/2. Who said it? Nathan, good job. 5/2. X to the 5/2 power. You're not going to see a mixed fraction. I mean, if you wanted to think of 2.5, do you remember how to translate a mixed fraction to an improper fraction? You take 2 times 2, you get 4, add 1, you get 5/2. Remember that? It's been a while. E is interesting because exponent rule says we have to raise 8 to the 2/3 power. And we also have to raise x to the 5th to the 2/3 power. What's the rule when you do power to power? Multiply. What's 5 times 2/3? How many thirds? 5 times 2/3 is how many thirds? 10 thirds. Now, on your calculator, you can just do this, right? 8 to the 2/3 power. You could do it in your head. What root are we taking? Cubed root of 8 is 2, and then you're going to have to square that 2. 2 squared is 4. You type that into your calculator, though, you'll just get 4, and then x to the 10/3 on your own. Okay? And in F, again, we have a radical. We have some exponent rules right off the bat in the numerator because we have a set of parentheses being raised to a power. So the 27 has to be raised to the 1/3 power. It's the same as the cubed root, right? The x has to be raised to the 1/3 power. And then our denominator is 6x to the 1/2. So starting with 27 to the 1/3 power. If you have to type that into your calculator, go for it. But it's the same as the cubed root of 27, which I hope we know. What's the cubed root of 27? 3. And then we have over the 6, and then we have x to the 1/3, x to the 1/2. I'm leaving everything else the same right now. Now it's strictly exponent rules and simplifying. 3/6 reduces to 1/2. X to the 1/3 divided by x to the 1/2, we're supposed to do what with those exponents? Subtract 1/3 minus 1/2. That's going to be 2/6 minus 3/6, which is, what's 2/6 minus 3/6? X to the negative 1/6. Are we allowed to leave negative exponents in our final answer? No. So 1 over 2x to the positive 1/6. And if this was a multiple choice, and so that would be the final answer in exponential form. There's also a final answer in radical form. 1 over 2, and then what does x to the 1/6 turn into? We go back to radicals. 6th root of x. Excellent. I'll give you a minute to breathe here. Any questions on any of this so far? Let me go on the back, because I think I put one on here that actually was on the Regents. This one. See how there's this mixture of radicals and exponents? Okay? Use the properties of rational exponents, kind of what we just learned, to determine the value of y. So they pretty much want you to simplify the left-hand side into x to some power and figure out what that power y is going to be. Okay? The fact that x has to be greater than 1 is just kind of a fine detail. Doesn't really matter. You can't do this if your base is a negative number, so they're just saying that. But essentially, simplify this. We don't really have radical rules. We have exponent rules, correct? So anything, if you want to start simplifying, get everything in exponential form first. So I'll work to the left. How do I rewrite the numerator in exponential form? McKenna. Perfect. 8/3. So now it's in exponential form up top. The denominator is already in exponential form, but I can already apply an exponent rule. What can I do right now to the denominator? What can I make and turn x to the 4th to the 1/3 into, Cameron? It's, which x, is it a common base rule? Is it a power to power rule? Is it a negative exponent rule? In the denominator, what rule are we even talking about? Power to power. And when you do power to power, you do what with the exponents? Multiply. 4 times 1/3 is how many thirds? 4/3. Now what exponent rule should we be applying? Common base division means subtract your exponents. Keep the same base of x. What's 8/3 minus 4/3? 4/3. So, x to the 4/3 equals x to the y. What's the value of y? 4/3. Good? Any questions on that? Let's go back up. How can I rewrite the numerator? Oh, geez. Kirsten. Say x to the 5/2, right, because it's x, if I take that piece by piece, it's x to the 1/2 first, then raised to the 5th, which then power to power means multiply x to the 5/2. Good? What can I do to the denominator? Mason. X to the 7/4, and really there's nothing I can do to that, so I'm just going to keep it x to the 7/4. Now what's my rule here? Subtract. So I need a common denominator. So 5/2 is really the same thing as 10/4. Are you with me there? Yes? 10/4 minus 7/4 is 3/4. So if I was going to give an answer in final exponential form, that would be it. Obviously my answers are not in exponential form, but which one is equivalent to x to the 3/4? McKenna. 1. Excellent. It's hard to say if they'll leave the final answer in radical form or exponential form. If it's open response, they need to tell you, leave your answer in exponential form or leave your answer in radical form. If it's multiple choice, make your decision based on the options, right? Because these would both be simplified answers. It's just one's in exponential, one's in radical. And look at exercise 4. Take a minute on your own. Come up with your best guess there. Just look